Hello there. Today we will be doing number 6, product of array except self. So in this particular problem, we are given a list of numbers and we're trying to find out if we multiply every other item other than itself, what can we get for that particular position. So in position 0, 1, 2, and 3, we have 1, 2, and 3, and 4. And so for the 0th position, we can multiply 2, 3, and 4 to get 24. For this particular position, we can multiply 1, 3, and 4, which is going to be 12. And then for this 3 position, we multiply the 1, 2, and 4, except for the 3, which is 8. And for the last position, 4, we multiply 1, 2, and 3, except for the 4, which is going to be 6. And that's why the answer is 2, 24, 12, 8, and 6. So in this particular problem, we want to do this in O of n time. And we cannot use division. So with the O of n method, we can do this easily with division because if we multiply all the numbers together and we just divide it by its current ith position, we would have easily solved this problem. But this is a problem of how we can access the array with some creativity. And that basically means we're trying to skip multiplying this particular number when we get there. How can we do that? Well, one way is to multiply it from both sides. So for 1, we just multiply it from the right side. All the numbers from right side. For 2, we're just going to be multiplying all the numbers from the left side and from the right side. So let's take a look at how that looks. So on the left side, we have just the 1. Everything on the left side is just going to be 1. Everything on the left side is just going to be 2. And all the items on the left side is going to be 6. Now, on the right side, we're going to multiply everything on the right side of 4, which is going to be 6. We're going to multiply everything on the right side of 2. So that's going to be 2 times 4, which is going to be 8. Then we're going to multiply everything. This is everything on the left side. We're going to multiply everything on the right side, which is 3 times 4, which is 12. Lastly, we're going to multiply everything on the right side, 2, 3, and 4, which is going to give us 24 on this item. So this way, by multiplying everything on the left side and then multiplying everything on the right side and the left side, both sides, we can get a total, our particular number, skipping the item in the middle. So you might think that this is really difficult to code up, but after thinking about it, it shouldn't be too difficult. So let's get the left side, then let's get the right side, and then let's multiply them together. So left is equal to an empty array of 1 times nums. Well, lang nums. And the same for right. Now we have the left and right side. Of course, so what we do is we're going to do for I in range of length nums. It looks like we're using length nums multiple times here. Let's just define that as n. So what happens first? We're going to do some assignment. Left is equal to, let's say, the current product. The current product is times equals the current number, which is nums of I. So this is gonna increase until the point at which it's no longer until the end of the array. So it calculates we're multiplying every single item on the left side of that particular number. That means we're still missing the right side. So let's reset the current product to be equal to 1 and 4 I in range. Well, let's just like use the reverse nums. I think this way it's easier to code. Is it? Is it really easier to code? Because at this point, our I system's all way off. So I think it's better if we just do this. Reverse the processing. So right is equal to the current product and the current product times equals nums and I. Oh, right, left I, and the right of I at I. And with that, we have both the left and right side. So all we need to do now is zip these two together to get our answer. So that means for left and right in a zip of left and right, and we just need to multiply these two together. So L times R. Actually, we can do a list comprehension for this. And that's it. Let's check it out. It should work. And let's submit. Alright, so that was a pretty clean solution about what's going on here and how we're solving this problem. I think the only thing that's missing here is if we can simplify and reduce space usage, which I think the interviewer would ask you. But in terms of concepts, I think we've pretty much nailed it on the head about how to do this. And so let's think about how we are going to do this with 1, going both left and right. So instead of creating the product here, we could just multiply this into our product immediately. So this means if we just take, let's comment this out. And change some of these variables. Let's say this is the result. We're going to set the result equals to the current product. Next thing we're going to do is result times equals the current product. And we're going to return the results. Run the code. And let's submit. Wow, that is so much faster. Oh my gosh. Well, we basically reduce the memory usage. I didn't expect the time difference to be so much larger than our previously seen. But I think it was the third loop that created the discrepancy there, and also maybe due to random problems given here. But with this, we reduced the usage by one loop, and we reduced memory usage by one array. So, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.